Hi there. This week we embark on the last chapter of our calculus course. This is on integral calculus. There's two basic kinds of integrals. There's this thing called an antiderivative, and there's this other guy which looks pretty similar called the area. The antiderivative is a function, literally the antiderivative function, and the other one is a constant, a number, which represents the area between the function and the x-axis and between the given x values that are written on the integral sign. The fundamental theorem of calculus says that you can relate those two things. If you take the antiderivative function and you put in some numbers, specifically the x values, that will be the same thing as the area between those x values. The example I have here illustrated is the area under this parabola between x equals 1 and x equals 3 can be calculated by using the antiderivative function, plugging in the two endpoints 3 and 1 and subtracting and finding out that the exact area under this parabola is 8 2/3. There are a lot of different formulas that one can use to help find antiderivatives and therefore areas. There are literally hundreds and hundreds of them. I put some common ones on a reference sheet, but even there, it's just too much to try to memorize, and that is a very, very short list. So the ways of finding antiderivatives are a lot more complicated than just trying to find the correct formula to use. They require a lot of creative thinking and backwards thinking, and that is a lot of what Calc 2 is about. We'll be doing some of that next week, some of that more complicated, anti-differentiation stuff. But this week, we're just going to try to make sure we understand these two notations, antiderivative and area, and practice those. All right, well, please reach out if you have any questions, would like help on anything, or need further assistance with lab assignments, anything like that. I'd be glad to help. I hope you have an enjoyable week, and I hope I talk to you soon.